Hi there, welcome to my calculus review. Now in this presentation I'm going to bring all the calculus skills that we've learned, I'm going to bring them all together, and we're going to do that by going through some example questions. So first of all, these are the questions that we're going to be going through. The first question says calculate the gradients, and there's A, B, C and D, they're all different types of function. Calculating the gradient basically means you're going to have to differentiate. Question 2 is all about calculating the areas, and there's 3 different examples, A, B, C of those. They are all, as they're calculating areas, they're all questions on integration, and in fact they're all definite integration questions. And then the last question, you have to plot a graph, and you have to draw a tangent and find the gradient, and then you have to check your answer by differentiation. So that's a differentiation question really. Okay, let's just start going through these questions. So question one is differentiation, and it says calculate the gradients of the following functions at the point specified. So the first function is y equals 6x squared minus 7x plus 2. Now that equation is a polynomial equation, it's a power of x equation, polynomial equation. It's actually a quadratic equation, so 6x squared minus 7x plus 2 is a quadratic equation. We've got to first of all find the gradient, so we need to differentiate it. Now when you differentiate polynomials, you need to basically multiply the power by the number in front and then reduce the power by 1. So it's 2 times 6 becomes the number in front, that's 12, and we reduce the power by 1, so it's 12x to the 1, or 12x. Minus 7x just becomes minus 7, and the plus 2 just disappears. So our dy by dx is going to equal 12x minus 7. So that's the derivative, but the question did say calculate the actual gradient, so we now need to put a number in for x, and we know the number, we've been told that x is 2, so put 2 into that, so we get 12 times 2 and then take away 7, so it's 24, take away 7, which is 17. So the gradient of y equals 6x squared minus 7x plus 2 when x equals 2 is 17. Okay, the second question is another polynomial. It's just flipped around a bit this time. So we've got 12t minus t squared. Now this is s and t. So this time we need to put ds by dt equals. And then we differentiate it. So 12t just becomes 12. And minus t squared becomes minus 2t, so it's 12 minus 2t. If you're not quite sure about how to do that, you need to look at some of the previous videos which will show you how to differentiate polynomials. Now we've got the derivative, we now need to put in the value where we want to find the gradient, and we want to find the gradient when t is 5, so we put 5 into this, so it's 12 minus 2 times 5, or 12 take away 10, which will be 2. So our gradient of s equals 12t minus t squared when t is 5 is actually 2. The third question is a sine and cosine question. So w is a quarter sine t over 3 minus 3/5 cos 2t over 3. And we've got to find the gradient when t equals pi over 2. So first of all, we need to differentiate it. Now it's not y and x, it's not s and t, it's w and t. So it's going to be dw by dt equals. Now when you differentiate sine, sine becomes cos, so it's going to be cos t over 3. But you also need to multiply the number in front by the number in the bracket. Now the number in the bracket, well, the number in front first of all is 1 quarter. The number in the bracket is not 3. If you took the t out of that bracket, the number you'd be left with is 1/3. So we need to multiply 1/3 times 1 quarter, which is 1/12. So it's 1/12 cos t over 3. The second term is minus 3/5 cos 2t over 3. Cos becomes minus sine. So minus cos is going to become plus sine. And we need to multiply the number in front, 3/5, by the number in the bracket, 2/3, which gives us 6/15, and 6/15 is the same as 3/5, so 2/5. So we're going to get 1/12 cos t over 3 plus 2/5 sine 2t over 3. Now we've got the derivative. We now need to put the number in. Now this is a more tricky one. You've got to put pi over 2 into this equation. First of all, your calculator must be in radians. When you ever do calculus, your calculator must always be in radians when you're doing sine and cosine. So make sure your calculator is in radians. Then putting pi over 2 instead of t is not easy. I would certainly be using fraction buttons on my calculator, and I'd be using brackets in my calculator to make sure I didn't make a mistake on that. Anyway, when you put t is pi over 2 into that equation, you get dw over dt equals, and the first term becomes out as 0.0722, and the second term comes as 0.3464. So when we add those together, we get a gradient of 0.419. Okay, the last question looks odd. It's got percent in there and just an e in there, which is a bit confusing. Do remember, whenever you get two variables, you can always call them x and y if you prefer, and y and x. So percent you could replace by a y, and the t you could replace by an x if you wanted to, and that might help you. Certainly, we now need to differentiate it. So differentiating the first term is 100. Now this 100 is just a number. Whenever you differentiate numbers, they disappear. So that 100 just goes straight away. So we're only having to differentiate minus 100e to the minus 0.2t. That means you've only got one term to differentiate. And when you differentiate exponential functions, you multiply the number in front by the number in the power. So the number in the front is minus 100, and the number in the power is minus 0.2. And when you multiply those together, you get 20. So it's 20e to the minus 0.2t. Now we need to put 2.5 into that equation. So when t is 2.5, d% by dt equals 20e to the power of minus 0.2 times 2.5. Put it into your calculator carefully. Make sure that the minus 0.2 and the times 2.5 is all in the power. And you should get an answer of 12.1. So the gradient of that equation when t is 2.5 is 12.1. So the second question is all about integration. It's calculate the areas. So the first question is another polynomial. It's v equals 2t squared plus 3t minus 4. It's another quadratic. And we've got to find the area in the range between 1 and 5. Now, whenever you have to calculate the area of an under equation, you've got to integrate it. So you need to remember the rules. So first of all, integral of v dt is going to equal, now we need to increase the power by 1, so that becomes 2t cubed, and we then have to divide by the new power. So 2t cubed over 3. The next term will become 3t squared over 2. The minus 4 will become minus 4t. If you remember, when you differentiate, 4t would become 4. So now we're going the reverse way. So 4 becomes 4t. So the answer to the integral is going to be 2t cubed over 3 plus 3t squared over 2 minus 4t. There would normally be a plus c, but because this is a definite integration, we're actually finding an area, we can ignore the plus c. Now you should write your integral inside square brackets, just like I've done there, and then put the limits where we're trying to find the area between. They go on the end of the square brackets. They should normally go at the top and the bottom, the higher one at the top and the lower one at the bottom. The actual type I'm using here, they look a bit more in the middle. They should really be a bit higher, but that's fine. That will show the square brackets. It's been integrated, it's inside a square bracket, and our limits are 5 and 1. So now we put the 5 value into that equation. Now when you put 5 into the equation, please be careful. You don't do 2 times 5 and then cube it. You must do 5 cubed and then times it by 2. Remember BIDMAS, you do powers before you do multiply. Anyway, when you put 5 into that equation, you actually get, the first term becomes 83.33. The second term becomes 37.5, and we subtract 4t, which is subtracting 20. and you get a final answer of, on that when you put 5 into that equation, of 100.83. Next we put 1 into the equation. Now this is much easier, putting 1 into equation. Whenever you cube 1 or you square 1 or you square root 1, you always get 1. So really this becomes 2/3 plus 3/2 minus 4. So when you add those up, you get a total of minus 1.833. So now we've put both limits in, all we need to do is to subtract your two answers. So subtract them in the higher one, take away the lower one, not necessarily the highest number, but the number you got when you put the higher limit in, and then you subtract the number you got when you put the lower limit in. So we actually get subtract 100.83, take away minus 1.833. Now you can see there you got a double minus. 2 minuses make a plus, so it's actually the final answer, and the final area is 103 units squared. I've rounded that to 3 significant figures. Okay, let's look at question B. Now question B is a sign question. It also looks quite different to the first question. First of all, it doesn't say something equals, it just says integrate between 0 and pi 3 sine 2x over 5 dx. Now it may look different, but really it's the same, almost the same type of question as you had in question A. You've still got to integrate it and you've still got to put limits in. It's just a different way of presenting the question. So first of all, we're going to integrate it, and when you integrate it, sine becomes minus cos, and we also need to divide the number in front by the number in the bracket. So we've got to divide 3 by 2/5. Now when you divide by a fraction, you can flip the second fraction upside down and multiply. You would get 15 over 2. So it's minus 15 over 2 cos 2x over 5. Our limits are at the end of the square brackets because we've integrated it now. The limits are at the other side. Now we need to put the pi value in. Now just like differentiation, when you're differentiating sine or cosine, your calculator must be in radians. And then you need to put pi into that. It's not too difficult to type that in. As long as you use fraction button and brackets, you should find that you end up getting minus 2.317. Then we put 0 in. Now when you've got cos, when you put 0 in, you actually don't get 0. So you need to be careful. Make sure you do put 0 in. Cos of 0 is actually 1. So be careful, but substitute x equals 0. And we end up getting minus 7.5. Now once you've got your two answers, you can now subtract them. So minus 2.317 minus 7.5, again we get another double minus, so it's a plus, and we get an answer of 5.18 units squared. And the third question, integration, is an exponential question. So p equals 9 e to the power of minus 0.03t. So it's integral of p dt. This is very similar to the first question, question A. So we get integral of p dt equals, now when you integrate this, most of it stays the same, except you've got to divide the number in front by the number in the power. So we're dividing 9 by minus 0.03. And when you do that, you get minus 300. So it's minus 300 e to the minus 0.03t. We put that in square brackets because it's been integrated. You put our limits at the end, 10 and 0. Now we put in the 10 into the equation. And again, do it carefully on your calculator. And you should get an answer of minus 222.2. Then we substitute 0 into it. And we don't get 0. Anything to the power of 0 is 1. So we're going to get minus 300. Then we subtract our two answers. Minus 222.2 take away minus 300. Again, a third double negative. Just so happens all these three questions have a double negative. And we get a final answer of 77.8 units squared. So that's all the integration questions. Right, question 3. This is the comparing differentiation with graphical methods. So we have to plot a graph. Then we have to find the value of h when t is 150. That just basically means you need to read it off your graph. And then by drawing a tangent, find the gradient at this point, and then check your answer by differentiation. Okay, so first of all, we need to use Desmos to plot the graph. Now, when you use Desmos, the website, you need to put this equation h equals 300e to the 0.005t into it. I suggest you use y and x instead of h and t. So y equals 300 e to the power of. Now, when you want to do it to the power of, you have to do Shift and 6 if you're on your keyboard. So if you hold the Shift key down and press 6, you should get a little hat, which basically means to the power of. And I think in Desmos it automatically then jumps your typing goes straight into a power. So type it carefully. I would certainly use brackets around the whole power. So I've got e to the power of bracket 0.05x, 0.005x. Well, when you do that, when you plot the graph, this is the graph you get. Now, I've labelled it, but apart from that, that's what you're going to get on Desmos. That's taken from Desmos. And in fact, when you first type it in, you don't see anything. You have to be very careful with this stuff. When you've typed in the equation, it may not appear, but that's probably because the range is wrong. You have to zoom in and zoom out till you find the range, the best range. Because we want to find the gradient when x equals or t equals 150, I've chosen the range to be between 0 and about 300. I've got 280 here. So that's the so my gradient's going to be somewhere in the middle. And I'm looking at the graph, I could see that the y range was roughly between 0 and 1,400. So I've changed those ranges to make it look the best I can. Your graph can look different. It may be stretched in some direction or squashed. Anyway, there's the graph. I next need to do is basically find the gradient, find the value when t equals 150. So I would look at the graph, look at 150, and look at that particular point there, that black dot, and I can read off the value of h. So roughly, I would say that value of h at x equals or t equals 150. The value of h is about 600. It's just a bit less than 650, so maybe 640 or something like that. Then the next bit we've got to do is to work out the gradient at this point. Now, to work out the gradient, we need to draw a tangent line. And drawing a tangent line is a straight line that just touches the curve at that point. So here's my tangent line, it's the blue line. It's just touching that red line at one point at that dot. And I've tried to make it as even as I can, so the line, I know it's a pretty accurate straight line I've drawn there. That's my tangent line. I need to find the gradient of that tangent line. So to find the gradient of a line on a graph, you pick 2 points. And I will try and space these out. I try and draw them, I pick 2 points that are actually on a line. So my first point I've chosen is this point here where it crosses the y-axis, where this tangent line crosses the y-axis. And I've called that my first point, x1, y1. That coordinate of that point is roughly 0, 160. Then I've chosen another point on the other end of the tangent line on this graph, which is my x2, y2 point. And that the coordinates of that point is 280, about 1050. Now I've got my 2 coordinates, I can now work out the gradient. So if we can remember the equation for working out a gradient, m equals y2 minus y1 divided by x2 minus x1. Difference in the y divided by difference in the x. So carefully put the right numbers in, and it's important you don't put them in the wrong place. So there I've put those 2 coordinates in, 280, 1050, and the other coordinate was 0, 160. And I can work that out. The gradient comes out as 3.2, and that looks right. It's a positive number. Every time I go along 1, it goes up roughly about 3.2. So every time I go across 100, I'm expecting it to go up about 320. That gives me that kind of, I know I've got roughly right the gradient now. So we've now found the gradient at t equals 150 by using the graphical method. But of course that took quite a while, and it's much easier to do it by differentiation, and in fact it's more accurate. So let's differentiate the equation. H equals 300 e to the 0.0052. So when you differentiate this, you need to multiply the number in front by the number in the power. So we're multiplying 300 by 0.005, and that comes to 1.5. So you get 1.5 e to the 0.0052. That's now differentiated. To find the gradient when t equals 150, we just need to put 150 into that equation instead of t. And if you do that and type it carefully in your calculator, you should get a gradient of 3.18. Now that's very close to the answer I got with the graphical method. They're not always as close as that, but this answer, this 3.18, is the exact answer. I have rounded it to 3 significant figures, but it is the correct answer. And obviously you can see the other answer was very, very close, partly because I drew a nice accurate tangent line. If your tangent line is not very accurate, you may find these numbers are more different. And that's it. That's my review of calculus.